welcome back to my YouTube channel. My name is Garabo Sitole, and in today's video we are doing counting principles. So I hope that after watching this video you'll actually get a better understanding of what counting rules are. So before I continue, if you haven't subscribed, please make sure that you click that subscribe button. Please make sure that you comment, like, and share. So let's get right into the business of the day, right? So as I said, we are talking about counting principles. So let me make you guys understand how counting principles fit into probability. So what happens is that when you are calculating the probability, the likelihood of an event happening, let's take for an example, you are tossing a coin, right? So how many outcomes can you have, right? Look at the term I'm using, the outcomes. How many possible answers can you have when you are tossing a coin? You can either get a head or a tail. And when you count those two, you can have two possible outcomes, right? So we are saying that what is the probability, for example, of getting a head? How many heads are there when you toss one coin? Only one head. So it's going to be the number of possible outcomes over the total number of outcomes, right? So with counting principle, we are focusing on the denominator. Let me write that down. I want to write it on your page. So as I said, with the probability, say probability of A is equal to the number of possible outcomes, right, over the total number of outcomes. So for example, getting a head, how many heads are there? 1 over the total number of possible outcomes, 1 over 2. So what I'm saying is that with counting principles, we are focusing on the denominator part, right? The total number of outcomes that you can have when an event occurs, right? But some events are not as easy as ones of things like tossing a coin, rolling a die, etc., right? So sometimes you have broad number of outcomes. For example, if we look at the number plays that you can make in South Africa, right? That's a huge number. That's millions. We're talking about millions. We're talking about billion number of possible number plays that you can make, right? So it's not as easy as when you're looking at the number of outcomes that you can have when you're tossing a coin and when you're rolling a die, right? So we use what we call counting rules in order to calculate the number of possible outcomes that you can actually have when that event occurs, right? Because the spectrum is so huge that you cannot just calculate, right, the number of possible outcomes. When you're tossing a 6-sided die, the total number of possible outcomes are easy to get. That's 6, right? When you are tossing a coin, the total number of possible outcomes are 2, right? So let's look at how then do we use the counting rules in order to determine the total number of outcomes that you can have. The reason why I'm explaining the relationship between our counting rules and our probabilities is that sometimes, actually most of the time, you'll be given a counting question, and then along with that question you are asked the probability of something. So what you have to first do is find the number of outcomes that you can have, the total number of outcomes that you can have using counting rules, and then right after that you can calculate the probability of a specific event occurring, right? So that's what counting rules are. So on a general case, let us look at this specific example that I have. So consider the following case. You have 3 shirts and 2 skirts, right? How many outfits can you actually make, right? Let's say the shirts that you have are blue. So the shirts that I have are blue, green, and red, right? Let us say that the skirts that you have, right, are purple and silver. I'm so sorry about the noise. Okay, let us continue. Okay, it is recording. Sorry. So let us continue. So as I was saying, you have 3 shirts, right? Let's say they are blue, green, and red, and then you have 2 skirts. Let's say they're purple and silver. So how many outfits can you make from these, right? You can have a blue shirt and a purple skirt. You can have a blue shirt and a silver skirt. You can have a green shirt and a purple skirt. You can have a green shirt and a silver skirt. You can have a red shirt and a purple skirt. You can have a red shirt and a silver skirt, right? So how many possible outcomes can you actually have? 2, 4, 6, right? So on an easy case like this, you can actually see that you have 6 possible outcomes. But then let us see the principle that this specific example is showing us. It's showing us that you need to take the number of outcomes that you have in one event and then multiply it by the number of outcomes that you have on another event. So you are going to say 3 times 2, right? And then which it gives you 6 possible outcomes. So the most important thing that I want you guys to always, and I say always, know with counting rules, especially when it comes to the basic rules that you have, which we'll cover, is that multiplication is very, very important. You normally multiply, right? So multiplication is very important. So multiplication is key, right? Let us look at an example where you're looking at the number of possible outcomes that you can have when you first toss a coin and then roll a die. How many possible outcomes can you have when you toss a coin? 2, right? Times how many possible outcomes can you have when you roll a die? A 6-sided die. 6. So the total number of possible outcomes you can have are 12 outcomes. Let us look at it. So you have 1, 2, 3, 4, 5, 6, right? You can get a head or a tail, head or tail, head or tail, head or tail, head, tail, head, tail, right? So let us count the number of possible outcomes that you can have. 1, 2. Okay, so you can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possible outcomes, right? So basically all you have to do is to take the number of possible outcomes on one event, multiply it by the number of possible outcomes in the other event, right? So if you guys are fine with this, let us now look at what the rules are saying. Okay, so what rules do you need to know? So I tend to separate the rules that you need to know into 3 categories. First of all, I look at the basic rules, right? Secondly, I look at what permutations are, and then thirdly, I look at what combinations are, right? So when we are looking at the basic rules, this is where you need to use your common sense. This is where you need to visualize what is happening, right? This is where you need to draw your lines. This is where you need to draw your boxes, right? So I'm not gonna explain the rules, but I'm gonna explain how you need to visualize it, how you need to draw the lines, right? So the first example says, the first rule says k of n, right? So that's the first rule. The second rule says when you're multiplying k1 times k2 times k3 all the way to kn, and then the next one says k factorial. So what I'm going to do after reading those rules, I'm going to show you where the factorial sign is on this specific Kaggle calculator. Let us look at 5 factorial, right? 5 factorial, so you press 5, shift this sign, x to the power of -1, and then there comes your factorial sign. What does factorial means? It means 5 times 4 times 3 times 2 times 1. So as you move, so 5 times 2 times, 5 times 4 times 3 times 2 times 1, right? So you're moving down, right? You're just multiplying. That's what 5 factorial means. Okay, don't worry, I'm going to apply this in an example and it's all going to make sense. So the fourth one, which is an interesting one in a way, it says that n factorial, so the number of items that you have, over n1 factorial times n2 factorial. So in this case, is when we're looking at things which can be repeated. And it's mostly things like when you are looking at the number of words you can have, right, when you're rearranging the letters of a specific word. For example, the example I'm going to use is one of books, right? So you would have to take the total number of letters you have over how many times are letters being repeated when you're looking at the word books, right? And then you divide by that. So that's what the basic examples look at, right? Don't worry about me not going through these rules. I'm going to apply it on an example, and I'm going to show you how you don't need to memorize these basic rules, but you need to be able to visualize it. This one you need to memorize or know in a way, right? Let's say there's 3, you just need to be able to visualize it and actually calculate it. Okay, let us look at what permutations are, right? So first of all, the definition or the formula for permutations is that you are going to take n factorial over n minus r factorial. So what we are doing with permutations is that we have n items, right? Let's say we have 12 people, but we want to take out 3 people from the 12, right? Hence it says from the 12 people, take out the 3 people factorial. However, it is important how we take out the 3 people that we need. It is important how we are taking out the r, right? Hence they say that order matters, right? So we are saying that n factorial over n minus r factorial. I'm going to repeat. So you have n number of items, you have 12 people, you need to take out 3 people out of the 12. So hence it says n minus r. So you have n and you are taking out r from the n, right? However, it is very important how you are taking out the r, right? Based on the specifics of the word problem you are dealing with. So order matters, how you are taking it out matters, right? So let us look at how we will know whether it's a permutation or combination. Just going to go over the permutation one. So these are the keywords that you need to look for. First of all, arrange. If they say how many ways can you arrange 5 books on a shelf, that's a permutation, right? Or how many, okay, so you have 5 books, how many ways can you arrange 3 books out of the 5? That's a permutation because you are arranging, right? The term there is arrange. There's a specific way that you need to order the items, right? The second one is order. In how many ways can you order the 5 books, right? In what order can you put 3 books out of the 5? For example, right? And then another thing is that with permutations, you're going to have specific characteristics that we are looking for when we are selecting something, no, when we are arranging something, right? So for example, they are going to talk about someone having specific skills, right? So that person is differentiated from the rest of the groups, right? For example, we look at Tembi, who has specific specific skills that are needed by the team, right? So they are going to talk about specific characteristics that separates the different individuals that we are arranging from, right? They are going to talk about different things. For example, they are going to talk about 9 provinces. These provinces are not identical. They are different places. So you know you're talking about a permutation in such a case. As I said, they are going to talk about specific roles, right? You have 12 individuals to choose from and you need 3. However, the 3 are going to have specific positions. One might be a CEO, the other one is CFO, and the other one is COO. So those are different positions. Each position is going to need different skills, right? So order matters. It matters how you are going to choose the individuals from the 12 that you have, right? And then they can also talk about things like 3 different prizes, right? You have prize 1 where you're getting 1 million, prize 2 where you're getting 500,000, and prize 1 where you're getting 100,000, right? Those are different prizes. It matters what prize you get, right? So order matters. You can't get the same prize for doing the same thing. The one who gets 1 million must have done something better than the one who got the second prize, better than the one who got the first prize. Do you guys see what they mean by order matters, right? There are certain characteristics that we are looking for in each individual, right? So that it differentiates that individual from the rest of the team. I hope you guys are getting it, right? And then we look at combinations. With combinations, we're just generalizing what permutations are, right? Because order does not matter. We just want to have 3 prizes, but those prizes are exactly identical. So it doesn't matter how the prizes are being given out, and it doesn't matter who's receiving the prizes because they all have different skills. So sorry, we need a team and we're choosing from employees that have the same skills. So it doesn't matter who we are choosing because they are all going to have the same positions. So with combinations, order does not matter. And this is the formula that you need to look for. You need to look that you need to know, not necessarily, but I'm going to show you how to do it on the calculator. But this is the formula: n factorial over r factorial times n minus r factorial. So just like with permutations, we are taking out r from n. However, with this one, it does not matter how we are taking out r from n, right? So what keywords should you look for? You should look for things like selecting, choosing, picking, drawing from, and grouping, right? As I said, the examples that I gave for this is that you have 3 prizes, but the prizes are the same. So it doesn't necessarily matter whether you give it to individual A, individual B, or individual C, right? They are all getting the same prizes. So order does not matter. Then you have 3 individuals. As I said, you're selecting a team of 3, picking from employees that have the same skills and are gonna have the same roles and responsibilities, right? It's all general, right? Okay, so let us look at how then do we use the calculator to calculate our permutations and combinations. So I'm going to show you guys how to do it on both calculators that I have. So these are the 2 calculators that I have. It's getting noisy outside, I'm so sorry. So, okay guys, there's a virtual session outside, so I'm just going to end this video and I'm going to continue when they are done because there's going to be a lot of background noise. So I'm just going to show you how to use the calculator and finish this video. I hope it was helpful. So when you're looking at combinations using this calculator, the basic casual one, let's say you're looking at 10 combination 3. So you're going to press 10, shift, the signs that you're going to work on in the calculator, the multiplication and division, right? So for example, 10, shift, let's say I want combination. It's written right here. I'm not sure if you guys can see, but it's written in yellow here. And combination, right? So you're going to have 10, shift, division sign, 3, right? And then you're going to have 120. Let's say you are looking for permutations. You're going to have 10, shift, but now you're going to do the multiplication sign, gives you P3, right? So that's how you would do the combination and thingy. But let us look at how to do it on the financial consultant calculator. So let's say you want 10 combination. You're going to press 10, catalog, go down, right, until you see C right here, combination 3. There you are. Let's say you are looking for 10 permutations. You're going to press 10, catalog, go all the way down until you get to P, right? Here's our P, permutation 3. This is what you get. So thank you so much, guys. I'm going to make another video applying, right, the basic ones as well as permutations and combinations. So I hope you guys stay tuned. I hope that this helped you guys understand what counting principles are, right? So as I said, with the basic ones, you don't need to memorize. You don't need to like stress about them. You just need to know how to visualize it. When it comes to the permutations and combinations, the most important thing is knowing how to identify whether order is important or not, so that you're able to apply the right calculator button, right? So thank you so much, guys, for watching. Please, I beg, please don't forget to comment. Please don't forget to subscribe. Please don't forget to like and share so that it helps somebody else. And if you see me, please give me a pen and a paper. Please donate pens and papers because I'm running out of stationery, guys. And I'm doing the best that I can to help where I can. So if you guys could please meet me halfway by donating books, papers in which I can write on, as well as donating pens. So thank you so much, guys. Bye.